Hi, this is Swapnil Bhartia, and welcome again to TFR. And today we have with us our regular Rob Hirschfeld in the Unpopular Opinion segment. And today we are going to talk about Redfish DTMF spec. Rob, first of all, what the hell is Redfish?
It's not something you eat. It is a DTMF specification for out-of-band server management, which means very little. Basically, servers and data centers have a primary interface that we use to run applications and things like that. And they have a secondary interface or baseboard management interface that allows you to control the machines sort of as a backup, like what would be the equivalent of a serial cable. People are probably used to something called IPMI, Intelligent Platform Management Interface, which has been around, feels like forever. And IPMI is very cumbersome and fragmented and hard to use. And some people in the industry got together and said, we can do better than IPMI.
Is Redfish a kind of standard, or is it a kind of suite of applications? What all does it composed of? Is it like different like tools or scripts? Can you talk a bit about the core of Redfish?
Of course. So Redfish is really a specification. It's an API that is designed for how you communicate into the baseboard management of a server. It does include there's firmware that is pretty commonly implemented for this, although not required. But it's mostly a set of specifications that describe how the machine will respond to these, out of power on, power off, set BIOS, set configuration, those types of actions for the machines. And then they've been extending it in some interesting ways where, server specs that you would get out of band, CPU, performance, heat, things like that, could actually be available through the API, but they could also be forwarded into another system for an analysis, which is an interesting feature that a lot of our customers are asking for.
So what all can you manage with Redfish?
So pretty much every system that you would need in the physical access of the system, right? Power on, power off, suspend, little things like blinking lights, which are super important. And blinking lights are actually one of the places where everything starts to fall apart, to people's surprise. And then items like setting RAID and BIOS configuration. How do you actually configure all of the components for the machine itself? All of those things are supposed to be available in Redfish, and more importantly, are supposed to be done in a consistent, standardized way for Redfish.
Right. And it's kind of, I don't know, but what is the right term, but it's kind of hosted or managed by DMTF, right? It's a kind of standard organization. What is that?
The specification is managed by the DMTF,
Mm-hmm.
yes. And so they have a committee and organization. The major hardware vendors are involved.
Mm-hmm.
So far, it's not going to sound. I'm not sounding like an unpopular opinion yet. But let's establish some baseline on where these things are going.
We will go there.
Well, and I think it's worth saying, right? They're doing they're trying to do the right thing. So they've been working a long time. They've been socializing the spec. It took a long time to get the major hardware vendors involved. There's universal consensus that IPMI is very long in tooth and hard to use and very frustrating for people. And so, there's a recognized need to have a consistent way to run servers, and ideally other pieces of gear also, using some standard protocols. And that would be a great thing.
Right. But doesn't, DMTF sound like old school where we used to have standard bodies? If you look at the model, of course, even we have OCI, which is for containerization, so I should take my words back. But still, these days, most of these things are defined by, it doesn't come from a standard organization. It comes from what is being, used in the industry, and then the whole industry move towards it, and then, kind of aligns with that. Even we see in a lot of open source projects, there are competing projects, but eventually they found here. So what I would want to understand is that if you look at, the Kubernetes scape or OpenStack you have been involved with, it comes more from the users. They use it, and that technology become popular, and that's where more people start. Like it doesn't come from a specific industry, which sounds more or less like bureaucracy. So, can you talk about the difference, how DMTF is kind of handling it, and if you have any unpopular opinion about that?
Here, this is the challenge with any of these platforms and these protocols. This is firmware, and it's baked into servers and shipped with servers. And so anytime you're talking about a something that has to be burned into the server as a management interface, the level of change and disruption that's required to propagate this is exponentially more than Kubernetes or some of these other things. So Kubernetes is just software, and I can patch software by logging into an operating system and changing a binary. Super easy. But when I want to ship a server, people, one is we don't have a lot of great tools. That's what RackN does. We actually try to improve data center operations and tooling around these things so that people can patch their servers. But when servers are shipped from the factory, they're locked in. A lot of customers don't have the tooling to change that easily or patch it or upgrade it. And then even when they do, it creates variation and delta that often breaks their data center tools. And so the challenge with any standard organization like Redfish is that it has to move very slowly, right? Redfish has a ton of XML baked into it, and it has these protocols and pieces that you're like, wow, this was designed 5-10 years ago. And it was designed 5 or 10 years ago. And that's part of the challenge with this, is that in order for something like Redfish to be successful, it has to be extremely flexible. Every server is a snowflake. As vendors innovate and add new capabilities in, those things weren't comprehended in the API spec, or one vendor implements a handle that's different than another vendor implementing a handle. And all of that variation is incredibly hard to comprehend in a useful spec. And so the unpopular opinion here is not whether or not Redfish is doing something useful. It is doing something useful. The unpopular opinion is it's not solving the problem, because we're not going to conform all of this heterogeneity that's in our data centers, needful heterogeneity in our data centers. We're not going to conform it into a spec like Redfish. And so the frustration that here is that if you think that Redfish is going to magically make Dell, HP, Lenovo, Cisco, and Supermicro and other vendors' servers uniform, you are mistaken, right? The servers have variation because they have to have variation. And the spec is going to have drift because not everybody is going to patch your servers, right? IPMI is varied and heterogeneous and hard to use because of the server space. Conforming everything to one thing makes the problem harder. That's my soapbox.
The whole idea of the software defined, in data center infrastructure is basically that you don't have to rely on a lot of things which are hard coded into the hardware itself. We are not talking black boxes anymore. So, as you already said, it's all API driven. So I just, see a kind of, contrast there. At one time, we were talking about, not you in general, but what we have seen in the industry, that you just buy white boxes, you don't have to worry about anything, just slap your software and it will just work there. So why do we really have to care about this?
No, this is a really important point. Just 5 years ago, everybody was frustrated with IPMI, and each vendor had their own protocol, their own interface for how they were going to handle out-of-band management. And that was also very frustrating. So if I was building tools, I do build tools for data center operations, and we have to accommodate Dell and HP and Lenovo and Supermicro and Raspberry Pi and things that only do IPMI. We have to accommodate all of those things. And the idea that Redfish would give us a API that we could write one spec and handle that one interface seems great. It seems amazing. The reality is it's what we call an N+1 problem. So in the data center, none of the things that went before it are going away anytime soon. And so if you have Dell servers pre-Redfish or Dell servers in dual mode, then you have to support the Dell out-of-band management and the Redfish out-of-band management. And then the Redfish actually has variations per hardware vendor. Because hardware vendors have different feature sets or different capabilities. And so it doesn't actually make the problem simpler. As a matter of fact, now we have IPMI, Dell Redfish, right? IPMI, HP Redfish. And the Redfish part is consistent. And I want to give the industry credit for this. It is consistent, but different still. And so our job as an automation platform, trying to create a consistent interface above all these pieces, our job hasn't gotten particularly easier because we have Redfish. We still have to track the quirks per vendor. We still have to track that things are different. And we haven't created this, Redfish hasn't created this substitution where Dell and HP and Supermicro, Lenovo, Cisco are swappable, drop-in swappable. That's the challenge, that we're thinking we've solved this uniformity problem, and we really haven't. That's not where the variation is creeping in.
And that is the whole idea of standardization, that you can just, if you look at electric plug, you can just put anything from any vendor, it doesn't really matter. But from what I hear from you is that, that is still, they are, as we have seen in other places, there are vendors' own distributions create a lot of interoperability issues within the industry. Is that the same thing that are happening here?
It's exactly right. And this, and I have a lot of friends in this industry, and I hope you're all listening to this, because I think we're making good progress. But I really don't want to keep hearing, well, Redfish is going to create this uniform data center in the back end, because that's not actually where our customers see the problems. They see the problems and things. Now, let me tell you my little story. Between Dell has a philosophy that lights shouldn't be off. An off light indicates no power, right? So you either have lights that are on or lights that are blinking. That indicates function. Other vendors have different philosophies, and an off light is perfectly acceptable. And operators can debate for hours over beers which is the right strategy, but they're different. And so the idea with turning on a service LED on a Dell server, there is no off. There is on or blink. And you think, oh, okay, that makes sense, I get it. That means the spec for how that operates is different, because the word off doesn't work on a Dell server, and you have to then decide how to map what off maps to, because it's an API failure if you go to off, and it doesn't go off. So, that one example is replicated all over the place in how these settings work and how things go and vendor differences. And I like this example because it's not right or wrong, right? It's just different, and it's not bad that it's different. It's different, and so we have to figure out how to embrace data centers that have good heterogeneity and diversity, and different vendors have different implementations. And the challenge of thinking that we're going to create one uniform control plane for that and make all that go away at the baseboard level, I think is overly optimistic.
Since we have talked about edge in previous conversation, where you also talk about edge-based data centers, what role is Redfish playing in that space? Because if you look at edge, of course, you gave an example of Raspberry Pi, but edge space is even more fragmented. People make boards that come out of Chinese vendors, and that boards may or may never get updated. I mean, it depends on who you're talking about, but it's much more diverse landscape than the 3 or 4 players in the big data center space. So is it a bigger challenge in that space, or that problem has been solved because it's a new, kind of relatively new field?
So one of the challenges with edge is there really is very little room for out-of-band management at all. And so if you look at what people have been producing, out-of-band management is often a secondary thought or not a thought at all. Raspberry Pis don't have out-of-band management or power controls for them at all. If you look at a NUC, you have to get a pretty high generation, expensive NUC just to be able to get power on. They have some remote management embedded capabilities, and those aren't even available universally in the system. So our idea that we're going to have out-of-band management or any real management capabilities for IoT devices is going to be a long time coming. And we're watching people build, on on-premises edge infrastructures out of Nooks and things like that without any consideration for how this would work. Be nice to see something like a Redfish spec more targeted for out-of-band systems, but it's going to show just as much heterogeneity as anything else. And so we really do need to think through what management looks like in these cases. But I would say if you think that you're going to build an edge data center and it's going to have Redfish and that's going to unify all these different platforms, then you need to think through what you're actually accomplishing, because it's going to be a long way coming from that perspective. Or if you're going to go to like an Open 19 or an OPC and get a uniform spec out of that, we have a long way to go, right, on how that stuff is going to work.
Rob, thank you for explaining a bit of Redfish. There was not that much unpopularity in this one. You have to work.
You haven't talked to the Redfish community. They're going to be up in arms that Redfish. I don't think Redfish is the panacea to solve all management problems.
So you have folks. You have to work a bit harder on the unpopular side of things. It was a bit too positive. So we'll work on that in the future one. But thanks for taking time out and doing this today, and I look forward to talk to you again next week. Thank you. Any closing thought that you have before we wrap it up?
People who believe that data centers and the physical layer data centers are going away and aren't worth considering really aren't paying close attention to how infrastructure has been moving. The days of just pasting VMs over everything and saying that was great and I don't have to worry about it are disappearing. We're moving into a place where the physical layer of data centers is actually very relevant to how things operate and how we manage and what the cost controls are, especially when we talk about edge. Cloud is not making data centers go away. Just the opposite. In some ways, cloud is teaching us the right way to run data centers. And the people who are using them are experiencing that. There's a lot of positive, very effective things coming into the physical layer and up of data centers.